In this video, we want to talk about mole concept. I want us to note that 1 mole of a pure carbon, carbon 12, is going to weigh exactly 12 grams, and it will contain exactly 6 point or approximately 6.02 times 10 raised to power 23, and this number is what we call Avogadro number. So it's going to contain these C12 atoms. And because of this, we define a mole as the amount of substance that is contained exactly in 6.0 times 10 raised to power 23 elementary entities. So of that given substance. So that is how we define it. And because of that, number of moles, we use N to represent it, is given as the mass of that substance divided by its molar mass. So this is number of moles is equal to this. So we use N to represent number of moles, mass over molar mass. For example, let's look at some of these previous questions. This one says, how many moles of iron are present in a pure sample weighing 558.45 grams? Simply, we say number of moles is mass over molar mass. Now, the molar mass of iron is 55.845 approximately. And the mass given to us is this. So number of moles is equal to mass, which is 558.45 grams, divided by the molar mass, 55.845. If we divide this, we're going to have 10 moles. These other questions say, what is the molar mass of the substance if 0.4 mole of the substance has a mass of 25.0 grams? These are the options given to us. Now, from the same relationship that we have, that number of moles is equal to mass over molar mass, we can make molar mass subject of the formula. So molar mass becomes mass over number of moles. The mass given to us in the question is 25 grams. And then the number of moles is 0.4. So when we divide that, we're going to get 62.5 gram per mole. In this question also, we want to solve. It says, how many moles of limestone will be required to produce 5.6 grams of Ca, that's calcium oxide? And so these are the options. So what we're going to do is, number of moles is mass over molar mass. Now, what is the molar mass of calcium carbonate, which is limestone? So calcium carbonate, its molar mass, calcium is 40 plus carbon 12 plus oxygen is 3, so 3 times 16. So here is 48 plus 12, we have 60 plus 40, so 100 gram per mole is what we have, 100 gram per mole. Therefore, number of moles, which is 100, being under, mass being on top, the mass is 5.6, so 5.6 divided by 100, which is what we're going to get is 0.5, 2 decimal places, 0.56 mole. That is option D. Another question says, how many atoms are present in 6.0 grams of magnesium? So these are the options. Feel free to pause the video and try it for yourself. Now we continue. Molar mass of magnesium is actually 24 mole per gram, gram per mole. 24 gram per mole. it is given to us. So number of moles is equal to mass over molar mass. Therefore, mass is 6, molar mass 24. If we divide that, we'll have 1.51 times 10 raised to power 23. So when you divide this, you get 0.25. Now, for us to now get the how many atoms that are there, we will now multiply that. The number of atoms that are there will be given as 0.25 moles times the Avogadro number, which is 6.02 times 10 raised to power 23. And when we multiply that, we'll get 1.51 times 10 raised to power 23. Now, this other question says, how many moles are in 40 grams of sodium carbonate? So, these are the options given to us. Now, sodium carbonate actually is a strong base that is soluble in water, and also it has a cooling alkaline taste. So, for us to calculate its molar mass, we'll have 23 times 2 plus 12 plus 16 times 3. So if we calculate all of this, we're going to get approximately 106 gram per mole. Now, number of moles is mass over molar mass, which is 40 grams divided by 106 gram per mole, which will give us 0.377, approximately 0.38 mole.